Okay, and we have seen that already. We have seen that our three variables such as edu, GDP and INV are not co-integrated, so we can run unrestricted VAR model now, right? Because if the variables are co-integrated, only then we can run vector error correction model. But if the variables are not co-integrated, then we can run unrestricted VAR model, and that we shall do now. Okay, so we have to go to our statistics. So we have to go to our statistics to run it. Okay, I delete all the things. I just make it clear. Okay, so I go to statistics, multivariate time series, then I choose vector auto regressive model, right? Okay, here I take our three variables edu, GDP and INV, right? And here I take also lag 3. Suppose lag selection method has advised me to take the same lag, that is 3. So I have taken also 3 here. And time settings, here is observation and the data is yearly. So I click OK, and so everything is set. Okay, so that is our outcome of the model. You can see. Okay, this is the outcome of the model, and here you can see that is edu. So this one is the dependent variable, right? And these are all independent variable. Edu lag 1, edu lag 2, edu lag 3, GDP lag 1, lag 2, lag 3, and INV lag 1, lag 2, lag 3, and constant. And here is our coefficient. This is coefficient, and this one is the standard error, and this one is the Z statistics, and this is the p value, probability value. Okay, first I talk about 1.30 Z statistics. How to get 1.30? The coefficient 0.21 divided by standard error, that is 0.16, we can get the Z statistics, that is 1.3. So also suppose this divided by this, you can get this Z set statistics that we get all the time, and the corresponding probability. Okay, and here so so this thing will happen for all the model, right? So we have actually three dependent variable. One is edu, one is GDP, and one is INV. And here actually there are all the time two issues. One is long run causality, right, and one is short run causality, right. There are always two issues, but here in this model there is no long run causality because the variables are not co-integrated. So there is no long run causality, and here is only short run causality, right. Short run causality running from independent variable to dependent variable, right. And here all the coefficient actually are short run coefficient, right. These are all short run coefficient. Okay, suppose I talk about edu lag 1. Edu lag 1, this variable is not significant. Why? Because the probability value is 19.5%, which is more than 5%, meaning that edu lag 1 variable is not significant to explain our dependent variable, which is edu. Okay, then I suppose I talk about this one, L3, GDP lag 3, right? This variable, what is the probability value? Is very small. The probability value is 0.7%. 0.7% means less than 5%, meaning that this GDP lag 3 is a significant variable to explain our dependent variable, which is edu, right. So also, but here you can see most of the variables are not significant, right. They are okay. What about here? What about the next model? Okay, I can talk about, when I talk about this one, I talk about this variable GDP lag 1. Yes, GDP lag 1 is a significant variable because the probability value is very small, less than 5%, meaning that GDP lag 1, this variable is significant to explain our dependent variable, which is INV, right. Okay. Okay, now we can talk about short run causality as a whole, right. We can talk about short run causality. So short run causality means jointly, right? Jointly they are significant or not, right? Jointly. So that we want to check now. So meaning that suppose I talk about jointly. Suppose L1, L2, L3, right? These three variable of GDP, that means GDP lag 1, GDP lag 2, GDP lag 3. So they are jointly can cause INV or not. That we can check, right? And we can call it Granger causality test in the short run, right? Short run. So we can do it easily, right? We can do it easily from the Granger causality test. So I go to statistics, right? I go to statistics, then I go to multivariate time series, then I go to VAR diagnostic test, then I choose the Granger causality test, right? Granger causality test. Then okay. Okay, so this is the outcome of the Granger causality wall test. This is also called wall test. So you can see. So this one, you see, this is dependent variable, right? Okay. So what is the null hypothesis? GDP, all the lagged variable, all the GDP lagged variable, right? All the GDP lagged variable does not cause ADU. That is the null hypothesis. All the GDP lagged variable does not cause ADU. So that is the null hypothesis. That means all the GDP lagged variable, they are equal to 0. I just show you. You just check GDP ADU, right? I go up, GDP ADU. So ADU is the dependent variable. So here our null hypothesis is lag 1, lag 2, lag 3, they are all 0, right? They are all 0 to explain our dependent variable, which is ADU. Okay, so that is the null hypothesis, and the corresponding probability is how much? 1.2%. The probability, you can see the p value 1.2%, which is less than 5%, meaning that we can reject null hypothesis, meaning that they are not 0, meaning that there is a short run causality running from GDP to ADU. Okay. Then I talk about the second one, the lagged variable of INV does not cause ADU. That is the null hypothesis, and the probability value is 80.7%, which is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis. That means INV, that means there is no short run causality running from INV to ADU, right? But the thing is that when I consider all, that means these two variable, right, then the probability value is less than 5%. That means that means that means we can reject null hypothesis. That means that all these two variable that means there is a short run causality running from GDP and INV to ADU as a whole, because we can reject the null hypothesis. So in the same way I can explain this one, ADU to GDP. What is the null hypothesis? ADU does not cause GDP. That is the null hypothesis, and we can reject it. And what about this one? Yes, we can reject the null hypothesis, meaning that there is a short run causality running from INV to GDP. And also this one, we can reject null hypothesis, and here we cannot reject null hypothesis. We accept null hypothesis, meaning that there is no short run causality running from ADU to INV, and this one we can reject, and here also we can reject the null hypothesis. So that is the outcome of the short run causality, right? Okay, now we can talk about the whole model. Okay, here I can show you one example, just one example. Suppose this Granger causality test we can also find out in other way. The same result we can get it in other way. So here I am giving only one example. Suppose I take this one, right? This is the value I take, right? This is the value I take, and I can do it in other way also, right? The same result I can get it in other way. So here ADU is the dependent variable and GDP is the independent variable. So I go to statistics, and here I go to the post estimation, right? I choose post estimation, I choose test, I choose test linear hypothesis, right? Okay, then I have to create the specification. So create it, and I put it coefficient in specific equation at 0, and our dependent variable I choose ADU and test this coefficient. So I take all GDP lag variable as planned, right? I take these 3. That means these 3 become 0, right? That is the null hypothesis. So I click OK. I click OK. So you can see, so this is our command, right? lag 1, lag 2, lag 3, they are all 0, right? And the thing is that the chi-square value 11.02 and the probability is 1.16%, meaning that we can reject the null hypothesis, meaning that they are not 0. Okay, the same result 11.02 and 0.0116 we can see here. You can see this one, right? This one from the Granger causality test, and this one is the same. So there are two ways to get the result, the same result. There are two methods. Okay, now the thing is that whether the model as a whole is good or bad, that means we shall be checking diagnostic checking. So diagnostic checking of this VAR model. So I go to statistics, multivariate time series, then I go to VAR diagnostic and test. Okay, first I test about whether the residual are autocorrelated or not. That I check first. Okay, here I keep 2. Then I OK. So that is the outcome of the Lagrange multiplier test. So here I have taken lag 1, lag 2, and our null hypothesis is there is no autocorrelation. And at lag 1 and at lag 2, you can see the probability value 46.21, and here the probability value is 31.84%. So all are more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis. So meaning that there is no autocorrelation in this VAR model, and that is desirable. The model should not have any autocorrelation, and it is not here. So the model is well specified. Okay, then we talk about whether the residuals are normally distributed or not. We have to check. So as before, I go to statistics, multivariate time series, then I go to VAR diagnostic test, then I come here, test for normally distributed disturbance. I click it, select it, and here I choose only Jarkabera statistics, right? That I select Jarkabera statistics, then I press OK. So this is the outcome of the Jarkabera test, and here we have 3 models. What is the null hypothesis? The null hypothesis is residuals are normally distributed, and that is desirable. So first I talk about our first model where ADU is the dependent variable, and here the probability value is very small, less than 5%, meaning that we can reject the null hypothesis. That means residuals are not normally distributed. For the first model, which is ADU. And what about second model, GDP? So here the probability value is 32.59%, which is more than 5%. So here we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that the residual in the GDP model are normally distributed, and that is desirable. And the third model, residuals are not normally distributed because the p-value is very small. But as a whole, when I take all these three variables, then we can reject the null hypothesis, meaning that residuals are not normally distributed, which is not desirable. That means here got some problem. Because residuals are not normally distributed, and that is not desirable for a model. So thank you very much for being with me for a while.